Welcome one and all. The topic is physical model, which is a part of system models in distributed computing system. There are three ways to view distributed models. They are physical models, which is mainly based on the type of computers and interconnecting networks. Second one is architecture models, which is explained in terms of computational and communication tasks performed by the system. And then the last one, fundamental models, which are divided into three, like interaction models, failure models, and security models. So for this presentation, we will be focusing on the first one, that is the physical models. Physical model, it is describing a system by its hardware composition of computers and networks. A physical model, it is a representation of the underlying hardware of a distributed system that abstracts away from specific details of the computer and the networking technologies involved. So basically this model is concentrating on the hardware part. What is the type of hardware and what is the number of hardwares involved, how they are connected, all that details will be explained by the physical models. There is a term related to this called baseline physical model, which is a very basic version of this. The hardware and software components located at the networked computers. They are communicating and coordinating their actions only by passing messages. That model is called baseline physical model. They are very simple physical model for a distributed system. We can classify the physical model of distribution systems in three generations. The early distribution system, which is you can locate in the years of 1970s and 80s, where LAN technology was invented, which is having, they are making networks which is limited internet connectivity and supported a very small range of services, and there could be participating nodes of numbering ranging from 10 to 100. They are all connected by a local area network. And these shared resources by these components could be a shared local printers. We can share file servers, then email service, then file transfer across the internet. So these are the various services which was provided by the early distribution systems. The second one is internet scale distributed systems. From the name itself, the internet concept is involved in this. So emerged in the 1990s because of the growth of internet, an extensible set of nodes interconnected by a network of networks, and they incorporate large number of nodes and provide distributed system services for global organizations and across organizational boundaries. This was all made possible due to the concept of internet. How about the heterogeneity of the components? The first one was only limited to a very limited amount of heterogeneity was permitted. The first model, early generation distributed systems, physical models. Whereas in internet scale distributed system, the level of heterogeneity in such system is significant in terms of networks, computer architecture, operating systems, the languages employed, and the development teams involved. So on all these matters, some level of heterogeneity is allowed in internet scale distributed systems. So this is a outline of internet scale distributed systems. The various components in this diagrams are desktop computer, then there are servers, and then there is network link. So all these desktop computers, they may connect to a server, and that servers are linked to the network by using various links. And these global links can be through satellite links, the backbone networks, which can act as the backbone network. The third type is contemporary distributed systems, which is derived from the emergence of the following computing technologies. So, till the last generation, the number of nodes were increasing. So a contemporary distributed system, it has a large number of participating nodes. It was able to manage a very huge number of participating nodes. And along with that, it had some additional newly invented computing technologies like mobile computing, ubiquitous computing, and cloud computing. So, what do you mean by mobile computing? It is actually enabling your laptops or your smartphones to move from one location to another, like and still connected to the system. So, but in order to implement that, you need to have some additional capabilities like service discovery, support for spontaneous interoperation, etc. So, implementing this comes with this new additional responsibility of adding these new capabilities like what I have just said. And then there is ubiquitous computing. Ubiquitous computing, you can relate this with Internet of Things. So what do you mean by an Internet of Things? It is actually it's so many things are connected together, and these things are nothing but the system embedded into any type of devices. It could be any type of devices, like it can be a washing machine, or it can be your remote, it can be your fridge, anything, any device which is embedded. So that could be part of your system. You can make that as part of your system. So the architectures where computers are embedded in everyday objects and the surrounding environment. So that also has contributed to this contemporary DS. Then there is cloud computing, the last part. And you know that this cloud computing is nothing but like you're providing the services to the users. So this it is actually it could be a pool of nodes which is working together and which is providing a particular service to the demanding users. And in the cloud, it could be the service could be like a platform as a service or software as a service, which you might have heard of already. There are various cloud services like AWS, you have Microsoft Azure, etc., etc. So, like using this cloud computing, it has led to a move. That is, we are moving from an autonomous nodes performing a given role. We are moving from there to a pool of nodes that together can provide a given service. So, more availability, more scalability, etc. will be provided by this cloud computing. One of the fantastic examples for cloud computing is the search service offered by Google. Google is making use of a number of servers to implement its searching service. The fourth one is distributed system of systems. So what do you mean by that system of systems? You can define it like a complex system which is consisting of a series of subsystems. And the subsystems are systems in their own right. And when they all come together, they are performing the task. So that's a system of systems. And it is the emergence of ultra large scale distributed systems has contributed to this new term called distributed systems of systems. Very large number of participation here. And in one of the example, if you take an example for a environmental management system for flood prediction, it can consist of sensor networks So there could be multiple sensor networks which are deployed to monitor the state of various environmental parameters. For example, say the humidity, the temperature, the water level, whatever it is, so that it consists of that sensor network. So different types of sensor networks are deployed, and it could be coupled with systems like which is used to predict the likelihood of floods. They are maybe predicting it by running some complex simulations, etc. So this subsystem of sensor networks, they could be connected to another systems which are predicting the likelihood of floods. And additionally, after this prediction, this early warning systems can be provided to the key stakeholders via mobile phones. So one more system is coming into picture. So it's actually a system of systems. That's why the name DSS. So we can summarize what all we have discussed so far in this table. Let's take different properties of distributed systems. The scalability first, the scale. So the early distributed system, the scale was, or the number of participation we can say, that was very small. Then came the internet scale, where the number of participation has increased a lot using large scale systems. Then in the contemporary, you had an ultra large scale. So the number of participation has increased considerably in the third classification. Then there is heterogeneity. In the early distributed system, the heterogeneity was very limited. Usually, very relatively homogeneous configuration was typically taking part in the type of early distribution systems. In the internet scale, it was significant in terms of platforms, languages, and middleware. There was heterogeneity in terms of the platforms, the languages, and even the middleware. So it was significant in the internet scale distribution. Whereas in the contemporary, where there is a ultra large scale of participation, added dimensions introduced, including like radically different styles of architectures. So different dimensions were added in order to address the heterogeneity part of a contemporary distributed systems. The third one is openness. The openness of the computer system is the characteristics that determines whether the system can be extended and re-implemented in various ways. In terms of distributed computing system, the openness of that distributed system is determined primarily by the degree to which new resource sharing services can be added and be made available to the users by a variety of client programs. So the openness in the early distributed computing system, it was not even a priority because it was in a very infant stage. Using a simple LAN technology, some equipments or some devices were trying to communicate with each other. And then the internet scale distribution, significant priority has come with a range of standards were introduced. Whereas in the contemporary, which has got a very large scale, it's one of the major research challenge. So many research activities are going on regarding the openness of a contemporary distributed system. The fourth one is quality of service. Again, it is in the infancy stage of the early distribution system, whereas in the internet scale, the significant priority with a range of services was introduced. And still, this is also a research challenge with regards to contemporary distributed systems. Thank you all.